All right, so we'll just spend some time reviewing some quadratics here. So basically by the end of this lesson, you should hopefully remember everything from grade 10. And yeah, we'll just spend some time going over that. So first of all, you have 3 different forms of a quadratic. So let's just talk about those first. So you have standard form, you have, so you have standard form there, you have vertex form, and you have factored form. So let's just look at some of the keys for each of those 3 forms, and then we can go into some of these questions. So first of all, what is standard form? So standard form is basically the regular form. So when you have everything fully expanded out, so as ax squared plus bx plus c, one nice thing about this form is you can instantly see what the y-intercept is, because if you sub in x equals 0, that'll make the first 2 parts equal to 0. And so you have your y-intercept just like that. So that's always nice. For the next part, you also know the direction of opening. So if you have a positive number at the start, it'll open upwards, and if you have a negative number at the start, it'll open downwards. So those are a couple of the keys for that particular form. Okay, for vertex form, so to get to vertex form, let's say if you're in standard form, what you need to do is go through the process of completing the square. So that's sort of in this diagram right here, and we'll do that in the question below. But what's nice about vertex form is we write it out in this general format, ax minus h squared plus k. And what's nice is then the h and the k value, those 2 values make up your vertex. And the vertex of a parabola is basically, the starting point of the parabola, and then it either opens upwards or downwards from that starting point. And that also gives you the axis of symmetry, because it's symmetric around the vertex. And that axis will be a vertical line, so it'll be x equals to that x value. And again, the value at the front, it tells you if it opens upwards or downwards. Factored form, this is just let's say if you were in standard form, so if you were in your regular form and you factored it, then we call it factored form. Again, you can look out in front if there's any sort of negative or positive in the front, tells you which way it opens. But what's nice about factored form is you can right away tell your roots, which would be your x-intercepts. And we'll get more into that later in the unit. But you have your 2 x-intercepts just instantly when you have it in that nice factored form. All right, so let's go over actually practicing some of these, switching between the different forms and see how it works out. So first of all, let's identify which type of form we have and then switch it into the form that we want. So the first one, we have f of x equals x squared plus 4x minus 7. And that's originally in standard form. Now let's bring it into vertex form. So what we need to do is complete the square. So I'll just write that off to the side. So we're completing the square. So what do we need to do for this? So to complete the square, what we need to do is, first of all, what we're looking to do is we want to make a perfect square trinomial. So when we reviewed factoring and such, we did go over perfect square trinomials. That was at the start of Unit 3. But the form of a perfect square trinomial was that you had, let's say your first number was some sort of square, which is good. We leave the middle as is. But what we want is we want to convert this into something. So we need to add some numbers so that it's going to look like a perfect trinomial, or a perfect square trinomial. So if we take this 4, so our number 4 here, if we divide that number 4 by 2 and square it, so divide by 2, then square, what happens is you will get, in this case it just ends up being 4 again, that's just a coincidence. But what we want to do is just add that there. And then this creates a perfect square trinomial, because you have a square on the left, you have a square on the right, and the middle term is just this number. If you take the square root of that and divide it by 2, it gives you that middle term, which is what a perfect square trinomial would have. But since we added 4, you can't just add a number to an equation. You need to also subtract that same number, because that's equivalent to just 0 there. Okay. And now what we can do is we can just focus on the first 3 terms, so just focus on these parts. And what you should see is we will now use our factoring of a perfect square trinomial to turn it into x plus 2 squared, and the n part is minus 4 minus 7, which gives us minus 11. So there is our vertex form of that equation. All right, let's take a look at this one. So this one's going to be similar. We're going from standard form into vertex form. But let's first of all, we have this negative 2 out in front. Negative 2 in front is just not nice. We don't like having numbers in front of our first part if we're completing the square. So let's just factor that part out. So we factor out the negative 2. So we're just left with x squared. For the next part, you have plus x. So now that's going to become minus x over 2. Because if you were to multiply the negative 2 back in, you'd get back to plus x. And we only actually need a common factor from the first 2 terms, so you can just leave the minus 5 outside at the end. Doesn't need to do anything. All right, and now we just use the same kind of process we used before. So divide the middle term or the second term by 2 and then square it. And that's going to become, if you divide it by 2, you get 1 over 4. Square that, you get 1 over 16. And then subtract that as well. Keep that all in brackets because we haven't moved it away. And then what we need to do is we need to just want to change colors. We need to just multiply this negative 2 by this 1 over 16. Why do we need to do that? Well, the reason is because we're going to factor the rest of this as a perfect square, but you don't want that last part there, so we're just sort of pulling it out. So negative 2, that perfect square is going to be x minus, in this case, the perfect square ends up being, you take this second term, divide it by 2, so 1 over 4 squared. Negative 1 over 16 times negative 2 is just 1 over 8, so you have minus 5 plus 1 over 8. And then you could just figure out what is minus 5 plus 1 over 8 equals, and then you would have it in vertex form, because you have the front part as it should be. All right. So for part C, what do we have? So we have, for part C, we're just going into factored form. Well, I don't know what's happening there. So we just need to factor this. So look for 2 numbers that multiply to negative 15, so don't forget the sign, and add to negative 2. So just take a moment to think about that, but negative 5 and 3, positive 3, will do that. So negative 5 times positive 3 gives you negative 15, and 3 minus 5 equals negative 2. And you can always double check your work to see if it actually gives you that answer back if you were to expand the factored form. But yeah, that's all we're looking for that question. 1 step and that's it. For part D, you want it in standard form. So what we have is, we have it in vertex form there. So to get it into standard form, we just have to expand it. So just multiply it through. So what you could do is write x plus 3 squared as two separate things. You don't have to. I'm just going to do this to make it a little more clear, because sometimes what happens is people will forget the middle term when you expand this. So they'll get x squared, which is correct. But then if you look at it this way, you'll see that you'll have a 3x and another 3x, which will give you 6x, and then plus 9 is at the end. But sometimes a common error is just to say x squared plus 9, because it's easy just to like square both of those numbers and forget the middle term. And then just expand this 2 into each part. So 2x squared plus 12x. And then what you'll see is you have plus 18, but we have this minus 1, so I'm just going to right away write it as plus 17. And there we have it, into standard form. All right, the next part, checking if a quadratic function, or you can check a quadratic based off a table of values. So if you have constant second differences, then you have a quadratic. So, oh, sorry, I guess I accidentally clicked that. So what you can do is you can just, first of all, the difference is just basically taking the bottom number, subtracting the top one, or basically what do you have to do to go from 15 to 11? You just have to subtract 4. From 11 to 7, subtract 4. From 7 to 3, subtract 4. From 3 to -1, subtract 4. All right. In this case, we have constant first differences. They're all -4. So in this case, it's not a quadratic. This is actually a linear, or a line. So a linear function. Let's try the second one. So from 1 to 3, you have to add 2. 3 to 6, you add 3. 6 to 10, you have to add 4. 10 to 15, you add 5. All right, let's try it again. So now take the differences of these ones. So from 2 to 3, you add 1. From 3 to 4, you add 1. From 4 to 5, you add 1. So in this case, second differences are all the same, so you have a quadratic. All right, so we'll go continuing this sort of pattern. What do you do to get from 4 to 8? Add 4. From 8 to 12, add 4. If you go through that, you'll see that you have to add 4 each time. So again, this one's linear, not quadratic. And let's go through this last one. From 7 to 4, you have to subtract 3. From 4 to 3, you have to subtract 1. Then you have to add 1 to get from 3 to 4. And from 4 to 7, you have to add 3. And always be careful about your signs. It's easy to mix them up. And that will result in errors, because then you won't necessarily have constant differences at some stage maybe. So from -3 to -1, you have to add 2. From -1 to 1, you have to add 2. From 1 to 3, you have to add 2. So constant. So this one is a quadratic function. All right, so that's a review of section A there.